Example 1 just says determine the amplitude of the graph of each function. We're going to add to this, and we're going to graph each of these examples because this is the purpose, is to get us used to what these graphs look like. So in A, we have y equals 2/3 sine of x. Connecting to our transformations unit from before, we would recognize that our parent graph is y equals sine of x. And sine of x, you have to be able to go, oh, I know what that looks like. It goes up to 1, down to -1. And I can label my axes family quickly. A sine graph starts in the middle, going up, goes from your middle to your maximum to middle, back to a minimum, back to the middle again. And that's our parent graph. What does this do in transformations unit? Would that affect your y values or your x values? Would it be horizontal or would it be vertical? Is it inside the function or is it outside the function? It's outside the function. Since it's outside the function, it's going to be a vertical. In this case, because it's less than 1, a vertical compression. You would multiply your y values by 2/3. What does that do to our graph? Well, instead of having pi over 2 comma 1, instead of having pi over 2 comma 1, I have pi over 2 comma 2/3. Instead of having 3 pi over 2 comma -1, I now have 3 pi over 2 comma -2/3. And when my y values were 0, they're still going to be 0. And we find out that our amplitude is -2/3. In fact, we're going to use this as a shortcut that any vertical stretch or compression, we're going to label that as a big A out in front, and that big A out in front really stands for amplitude. Well, it's the first value, but it will always be your amplitude. The positive amplitudes are always positive because it's a distance from the center line to the maximum. And in this case, that distance is now 2/3 because we've had a vertical compression squishing it by a factor of 2/3. In part B, y equals -4 cos of x. Right? Our parent graph is y equals cos of x, so we quickly draw from 1 to -1, 2 pi, pi over 2, 3 pi over 2. Cos graph starts at your maximum, then goes center line, then minimum, then center line, then maximum. There's our cos graph. What do these things do? They're both outside. This will be a vertical reflection, and this will be a vertical stretch. Together, those multiply your y values by -4. So what does our new graph look like? Well, instead of starting at a +1, it now starts at a -4. If I multiply my y value, which is 1, by a -4, it would be at -4. Again, I'm going to label 2 pi and divide it into 4 equal sections. You're going to find that you do this quite often using your axes family. When I had -1 at pi, when I multiply that by -4, now at pi I have +4. And all my zeros stayed the same. And so here's my new graph. This distance from my maximum to my center line, my amplitude is 4. So even though there's a -4 out in front, we never say that our amplitude is a negative number. But whatever number appears in front of a sine or cosine graph, sine or cosine equation, will be the amplitude of your equation. Even if you've got other stretches, other reflections, other translations, and we're going to use this information to help us graph quicker. Okay, questions for practice on this one? 3A and B, 4, 5, and 9.